So what does NASA do to find out how a spacecraft will act before it's even built? Find out next on Real World.
NASA is designing a helicopter to actually fly on Mars.
The Mars Helicopter is what's called a technology demonstrator. Its sole goal is to show we can actually do this mission. Can we fly a helicopter on Mars? JPL has the primary responsibility for the Mars 2020 rover and the Mars Helicopter mission, and they branch out to expertise across all of the NASA centers to bring that together so that we have a successful mission.
But Mars is different from Earth, so how do these engineers test their ideas without actually having to go to Mars? Well, the answer is math. Math is not just a set of symbols and numbers. It's the language of the universe. And it's also a way for us to take complex ideas and turn them into equations that are then solvable. To understand how this is done, we're going to talk to Dr. Brian Allen, who's doing mathematical modeling for the Mars Helicopter. So you build models of the helicopter inside your computer with equations that will translate to an actual working helicopter on the planet Mars.
Right, so here I do computational simulations of helicopters and rotorcraft. So is it much different, a helicopter on Mars, than here on Earth? There's a big difference. One of the key problems is this thin atmosphere. The density of the air is very low, so we want to look at the lift, and we want to make sure that the helicopter is generating enough lift in this thin atmosphere. Right, and is able to carry the payload that they're interested in carrying. So when you build a simulation, there are certain quantities that have the ability to change, right? These variables. Right. So what are variables in your particular simulation? So in those simulations, we look at the density of the air. Right. As well as we're solving the momentum, the velocity. So now we can take these equations, we can look at them, we can simulate them, and we can redesign. Whereas in the past before, like simulations, you would have to build it, test it, try it. You know, okay, redesign it, and build it, test it. So it would be a lot longer without computational simulations. And how does gravity on Mars compare? Well, gravity is a little bit more than a third of Earth's gravity. Okay, so I could dunk on Mars. That's what we're getting at? We can get a much higher jump.
You can jump a lot higher, yeah. Complex equations will help us see how the Mars helicopter will function when it flies on the red planet. But equations like these can't be solved using just pencil and paper. Researchers rely on state-of-the-art computers and specialized software to build mathematical models. And places like the new Katherine G. Johnson Computational Research Facility will give scientists and engineers the tools they need to develop future missions to the Moon, to Mars, or wherever our imagination takes us.